Hi, this is Patel. In this lecture, we are going to look at the body which is subjected to suddenly applied load, or the load which is applied with the impact. While applying this type of a load, how much amount of strain energy is stored in the body, that we are going to look in this particular lecture. So let's get started with the first slide, that is nothing but the strain energy stored in the body when the load is suddenly applied. So sometimes in factories and workshops, the load is suddenly applied on the body, and that is very usual in the working condition or the practical life. For example, when we lower a body with the help of the crane, the body is first of all just above the platform on which it is to be placed. If the chain breaks at once at this moment, the whole load of the body begins to act on the platform. Now this is the case of the suddenly applied load. Now you consider the bar subjected to a sudden load. So what is sudden load? It's not the load with the impact. So we may say that the body was about to touch the surface. Body was about to touch the surface. It has not touched it, but there is a very minimum or the ignorable distance between the surface and the body. And if the chain breaks, then the body will suddenly fall onto the surface. That distance of falling is very small, or it could be nothing or none. So the entire load of the body suddenly applied to the surface, that type of a load is known as the sudden load. Now consider the bar subjected to a sudden load. Now we are enlisting all the parameters. The first one is the P, that is the load applied suddenly, area, length, Young's modulus, deformation of the bar, and the stress induced by the application of the sudden load. Since the load is applied suddenly, therefore the load P is constant throughout the process of deformation. So work done will give us the answer of the strain energy. So work done is nothing but the force into perpendicular distance, and in this particular case, force, that is the load that we are going to apply, and distance is the deformation that is happening due to the application of the load. So the load applied is, let's say we assume that it's P and the deformation is delta L. So the work done would be P into delta L. Next is, we know that the strain energy stored is nothing but the sigma square upon 2E into AL. We have just derived this equation in the previous lecture. If you have not seen it, then you are required to watch that particular lecture first in order to understand this. Next is since the strain energy stored is equal to the work done, therefore this strain energy, which one, that is sigma square upon 2E into AL, this strain energy is equals to work done, that is P into delta L. So instead of delta L, we can write over here sigma upon E into L. And if you make sigma as subject, then sigma is equals to 2 times P by A. It means that stress induced in this case is twice the stress induced when the same load is applied gradually. In our previous study, we have assumed that all the loads are gradually applied load, but now in day-to-day life, it is not compulsory that all the loads are the gradual load. Instead of gradual load, we may see a suddenly applied load or impact load. So this is how the effect of impact load or the suddenly applied load is look like. The strain energy is almost twice the stress induced is almost twice the stress induced with the gradually applied load. So once the stress is obtained, the corresponding instantaneous deformation and the strain energy may be found out. So here we complete our first derivation. Now we are going to look at the example based on it. So the first example data is over here. An axial pull of 20 kilonewton is suddenly applied on the steel. Here they have mentioned suddenly. Word is clearly mentioned. In the previous example, they have not mentioned any kind of the loading type. So that's why we have considered the by default loading as the gradual loading. So but here they have mentioned the sudden loading. That's why on the steel rod of 2.5 meter length and 100 mm square in cross section, we have to consider the 20 kilonewton as the sudden load. Calculate the strain energy which can be absorbed by the rod and take the Young's modulus 200 gigapascal. Now we got all the data. The first thing that we are going to do is to find out the stress. So when the load is suddenly applied, the stress is twice the stress for the gradually applied load. So for the gradually applied load, the stress is nothing but the P by A. That will give us the answer as a 440 Newton per mm square. So this is the stress generated due to the suddenly applied load. Now the volume of the rod can be calculated by length into area. This will give us the volume of 2.5 into 10 raised to 6 mm cube. Now if you want to find out the strain energy, then we are going to apply the formula of the strain energy, that is nothing but the sigma square upon 2E into V. Put all the values into this equation and simplify, then you will get the answer as 10 into 10 raised to 3 Newton per mm. Newton into mm, which is not per mm, or 10 kilonewton into mm. So this is how we completed our example based on the strain energy generated due to the suddenly applied load. Now what are we looking at next is the strain energy stored in the body when the load is applied with impact. So how does this load would look like? Generally this type of a load is applied with some height. So let's say in this diagram, load is P. In this particular diagram, load is P, and that is at the height of H from the collar. So if this load is allowed to fall freely from this height, then it will create the impact on the collar, and that type of a load is known as the impact load. So as per our discussion, the impact load is applied on the body when we lower the body with the help of the crane and the chain breaks while the load is being lowered. The load falls through the distance before it touches the platform. In that particular case, the load is impact load. Now consider a bar which is subjected to an impact load. So how much work is being done? So here the displacement work is nothing but the force into perpendicular distance. So the here distance covered is first of all the height that they are providing for the free fall, and later on the deformation happened due to this particular impact loading is delta F. So the total distance that we are looking at here is P into H plus delta L. So this is our total distance. Now the stored energy or strain energy can be written in this formula. We know that both are the same, work done and the strain energy. So equate both of them and simplify them, then you will get the equation in terms of this: sigma square equals into AL upon 2E minus sigma into PL upon E minus PH equals to 0. Now further, if we simplify this equation by multiplying both the sides by E upon AL, then our equation would look like this, that sigma square by 2 minus sigma into P by A minus PEH upon AL. If you simplify this equation, and we know that the solution of this equation is nothing but P sigma equals to P by A plus or minus under root P by A square plus 4AC. So this was the basic roots, or we can say that the basic solution of sigma that we have received through this particular derivation. But once the stress is obtained, it is not over yet. The corresponding instantaneous deformation or the strain energy may be found using the found out as usual. So the work done is nothing but the P into H. Now we are considering only the height for the distance, and instead of work done we can write this particular equation, simplify it, and you will get the sigma, that is the stress due to the impact loading, is equals to under root 2 times EPH upon AL. So this was the end of our lecture. We conclude our lecture over here. In the upcoming lecture, we will see few more concepts. Till then, thank you.